Good morning, everyone. Mrs. Vanders here. So today we're going to do our experiment in a different order. So we're going to do our experiment first and talk about something second. So let's get right into the experiment. So the first part about setting up an experiment is that you ask a question. So today I want to know what happens when you combine a lemon with baking soda. And then next, we do some research on what happens when you combine them. So I have a pretty good idea of what's going to happen. And for you guys, a hint about what's going to happen today is that it's kind of similar to what happened in our experiment yesterday. Next, we make a hypothesis. So we take our information that we have and we make a guess, an educated guess, about what we think is going to happen during the experiment. And the next part is we set up the experiment. So I have all the materials here on our tray. So I have a lemon and some baking soda. We're going to be adding food coloring so that we can see the reaction, and it's kind of fun to add some food coloring. The next part of an experiment is that we record the data or observations that we have. So I do have a sheet for our CASA students set up. So there's a lemon, and I would like you to draw your picture of what happens on the lemon during your observation. And for some of the older children, like the full day 5s or the elementary kids, I have a Google form set up for you on your Google Classroom. So you can find it there. And if you really don't want to fill that out, that's okay. You can draw an observation as well. And finally, after we have all of our information from our observations, we write our conclusion. So we analyze our data and to see if our hypothesis is correct. All right, now we are going to get to our experiment. Okay, so the first part of our experiment is something that if you want to do this at home, you are going to have an adult do because it involves a sharp knife and a lemon. So I'm going to cut the ends off the lemon so that we can have it stand on the tray. And then I'm going to cut the lemon in half. Let's move all this stuff out of the way. The next part we're going to do is we're going to poke into the lemon to break up the segments and release the juices from the lemon. If you've ever tasted a lemon and noticed it's kind of sour, that's because there's an acid in the lemon called citric acid. So pretty much anything that kind of tastes sour, when you have it, will have some form of acid in it. All right, and the next one, we're gonna do 2 because it's kind of fun to do. So let's break up this one. Just poke in the sections, make the juice, because that's what's going to react with your baking soda. All right, those look pretty juicy to me. The next part is we're going to add our baking soda. I have a tablespoon. It doesn't have to be exact. A lot of science experiments that we're going to be doing, it's okay if it's not exact. When you're doing it in a lab, it is important to... So I'm going to add some color on this one so you can see the difference with what food coloring does. You can see the reaction a little bit better. So that's the reason I'm going to do that. So we're going to put that on top. Oh, it already looks kind of like a volcano. So volcanoes are not quite the same. We call it a volcano because it flows over the side. And that's often what volcano experiments are doing. But it's not quite a volcano. Volcano has molten lava that comes out. But it also does involve some gas reactions when you have a volcano. So there's a lot of carbon dioxide that's released, and that's what's happening with this experiment too. So the one with the color kind of shows up a little bit better. So that's why I added the color. Do you notice what's happening? So this is the observation. What's happening on the lemon? So it's bubbling and it's flowing over the edge. I keep poking it to release more of the acid so that it can react. And the other thing you can do if you'd like is you can add some more baking soda to see if it'll react some more. Make another big... But sometimes, if there's not enough acid left over, it might not do that. but it's doing it for me. Here we go. See it bubbling and foaming? Let's poke them. So that is our lemon volcano. So what's happening is that the baking soda and vinegar are combining together and they're making carbon dioxide, which is causing these bubbles to form. So now we are going to talk, nope. There we go. So now we are going to talk about volcanoes. So here's a good picture of a volcano. So I'm going to give you some interesting facts about a volcano. So volcanoes are holes in the Earth's surface where hot magma and gas. Volcanoes are holes in the Earth's surface where hot magma and gas from deep underground are released. Over time, volcanoes grow into tall mountains made from hardened lava and ash. Volcanoes are often found along the boundaries of tectonic plates, where sections of the Earth's crust meet. There are volcanoes on every continent on Earth. Volcanoes sometimes erupt. Lava flows down the sides of the volcano. Gas and ash are released into the air. When the lava hits the air, it hardens and turns into rock. Active volcanoes still erupt frequently or are expected to erupt soon. Dormant volcanoes are unlikely to erupt again. Extinct volcanoes will never erupt again. Scientists can measure the amount of magma inside a volcano to determine if it will erupt soon. There are also volcanoes on other bodies in space. Io, one of Jupiter's moons, has hundreds of volcanoes. So now we're going to talk about the parts of the volcano. So they're all labeled. So this is the ash cloud right up here. And an ash cloud is formed by volcanic explosions. I'm going to use the pen. And then this is the central vent right down here. And the central vent is an opening in the Earth's surface where magma rises from the magma chamber and volcanic materials escape. And then this part right here is the cone. And the cone is the area that is built up by ash and lava surrounding the central vent. And then at the top here is the crater. And the crater is the top of the volcano where the ash, lava, and gas escape. It surrounds a volcano. So this is the crater. The crater at the top of the volcano where the ash, so this is the crater. The crater is the top of the volcano where the ash, lava, and gas escape and surrounds a volcanic vent. And then here is the magma down here. And the magma is molten rock from inside the Earth. And then we have the magma chamber, which is down here. And that's the area in the crust where the magma collects after it moves up from the mantle. And then we have the lava. So the lava's over here flowing down the side. So lava is formed when magma is exposed to air and solidifies as it cools. And then we have some side vents, which are right here. And the side vent branches off from the central vent. And then there's sill. So the sill is here. And sill is hardened magma between layers of rock. So now we are going to talk about the shapes of volcanoes. So these are the shapes of volcanoes. So I'm just going to read to you the different shapes. So I'm going to read to you about the shapes of volcanoes. So most volcanoes have the same basic structure, but volcano shape and size varies considerably. The elements that all volcano types have in common are the crater, which is the mouth of the volcano where lava, ash, and gas escape, the magma chamber, where the lava collects after moving up from the mantle, and the central vent, which leads from the magma chamber to the crater. The biggest variation in volcano structure is the structure surrounding the central vent, called the edifice. The edifice is built up by the volcanic material that escapes as the volcano erupts. The composition, shape, and structure of volcanoes are determined by the nature of the volcanic material and type of eruption. So the three most common shapes are stratovolcano, shield, and cinder cone. So this is a stratovolcano. So stratovolcanoes are the large volcanoes with steep slopes that are the most familiar shape. They usually have more than one vent. Stratovolcanoes are also known as composite volcanoes because they are created from cinders, ash, and lava spewed during different eruptions. Cinders and ash pile on top of each other, lava flows on top of the ash where it cools and hardens, and the process repeats. Stratovolcanoes tend to have highly infrequent eruptions, usually hundreds of years apart. Examples include Mount Fuji in Japan, the Mayan volcano in the Philippines, and Mount Vesuvius and Stromboli in Italy. So the next is the shield volcano. So shield volcanoes is a large volcano with gentile slopes and usually have several vents. The sides of a shield volcano are made of many thin layers of lava. This shape of volcano is formed by fluid lava, which flows very quickly and can cover a large area before it hardens. It is named for its low profile, which resembles a warrior shield. Shield volcanoes are more common in oceanic settings. The Hawaiian volcanic chain is a series of shield cones, and they are also common in Iceland. And then the last one is the cinder cone. So the cinder cone is the smallest and most common shape of volcano. Cinder cone volcanoes have steep, symmetrical sides and one vent. They usually erupt violently, spewing chunks of lava into the air. The lava hardens around the vent, building up a cone shape over time. Most cinder cones erupt only once. The Sunset Crater in Arizona is an example of a cinder cone. In New Mexico, the Caja del Rio is a volcanic field of over 60 cinder cones. All right. And now we are going to talk about the layers of the earth, because this is important, because that is where all of the molten lava comes from. All right, so the first part of the layers on the earth is the crust. So the crust is the outer solid layer. The crust is the outer solid layer, and this is where life exists. It is between 3 and 44 miles thick. This thin layer covers the outside of the earth and consists of solid rock. The thin parts are the oceanic crust, and the thicker are the continental crust. And then the next part is the mantle, here. The Earth's mantle is the thickest layer at 1,800 miles thick, and it makes up about 85% of the Earth's weight. It is made of molten or metal. It is made of molten, melted iron, minerals, and other semi-solid rocks that flow under pressure. This can cause the surface plates to shift and crash into each other, causing earthquakes and volcanic eruptions. So the mantle is what causes all the volcanic eruptions, and that's where all the molten lava comes out of. The outer core, which is this part, this layer is 1,400 miles thick. This liquid layer consists of melted iron and nickel. The outer core flows around the center of the Earth, and the movement of the metals creates our planet's magnetic field. And then this part is the center. So the inner core. This layer is 800 miles thick and is found in the center of the Earth. It consists of solid iron. The temperature of the inner core is hotter than the surface of the sun. The metal stays solid because of the incredible pressure surrounding it. So the earth is what causes the pressure. I hope everybody learned a little bit about volcanoes and enjoyed our lemon volcano today. We'll see you tomorrow where we get to learn a little bit about microorganisms. Bye everyone!